Fajnie, gamta tai fajnie, man trūksta dalyką tarp šito asfalto ir dangoraižio iki gamtos. Bet jau į kaimą nuvažiuoti, tai dabar. Gamta tai fajnie, man trūksta dalyką tarp šito asfalto ir dangoraižio iki gamtos.
Irgi turiu tokių atsiprašau, nes aš turiu dirbu viskas, ir viskas panašus. Ir vat panašiai kaip tu. Man sakau, va taip. Aš dabar pasumau skaičiuoju. 21 metų. Kiek čia yra? Aš taip, kiek pamenu save, iki 25 tai buvo iš viso. Nu, po to pradėjau galvoti, nes iki 25 tai kažkaip pabutimą dalis galvoju, o po to dabar pradėjau. Nenori, nesigauna. Taip sėdė ir žiūrint, aš žūrą žinau, taip seniausias, taip žiūrint. Nes žūra jau buvo nuo versijos, seniausias, viskas per galvotą. Čia jisai bando pasivyti, bet jis pigesnis. Iš vienos pusės resursų pigesni, skaičiukai gražesni, bet jūs ability tai ir pas jos visi servisai vyti. Tiek, kad išlikom fainus labai, nes visą laiką. O ne komplain. Tai va, bet dabar tikrai labai daug yra faktų, kurios eina, nes labai stipriai bando paimti rinką, nes kas tai žuvis tai labai. Jie bando įleisti, jie muša kainą ir tada visi enterprise iš tipo griežti. O tų žmonių nėra daug, nes nieks nenori iššūkti. Štai, kad jis ir čia įsigypas ir žiūri, kad tau reikia kodą rašyti, kad aš negaminti. Niekas nenori, 10 metų viskas su to, ką panašu. Tai jeigu yra kitų,
kur normaliai, tai ką panašu. Ir va, nėra daug žmonių. Nes dėl to, žinai, reikia aukščiai yra ir bet iš tikrųjų, bankas savo nori 4 metų išvyniau. 2 metus, kai atsirado normaliai salės, 4 metų nori. 4 metų ne. Samtiki tie, kurie meluoja, ir paskui užvičiu paėmė. Bet dėkingiausi tie, kurie čekina mano atsirekia. Super pokalbis, bet čekina. Ir paskui 2 savaičių koks downtaimas, mes nu, gali rašyti, jo, dar vienas, kaip aš DevOps.
Čia visi tipo.
Nesuprasiu, kas pradėjau su programu rašyti, su Python,
Dabar aš esu, man atrodo, aš kaip dabar ieškau darbuotojų, bet, pavyzdžiui, dabar, kad aš žinau, kas 5 metus, ir sėdėjau viską pavyzdį.
viskas gavo hello, grįžta gal komanda. Ir ten neteisi loginis, pasižiūrėsiu, kur čia kompromisas. Gerai, malonu.
Testing. Oh, don't knock the laptop.
Which one?
Well, we were going to use the camera which was up there, but unfortunately it's not working, so I'm having to actually try and record this from my laptop. So it's going into Zoom to be recorded, and then I'm experimenting with live streaming it to YouTube. So if you go onto the WInOps channel on YouTube, you are currently live. So I think it's quite exciting. First time we've ever done that. So yeah, hopefully it'll be right. I would just ask that those people who are close to the laptop, don't talk too much, because you will be everybody will hear every single thing people say. So welcome. For those of you who don't know me, I'm Steve Thayer. I'm the co-founder of DevOps Group and co-founder of the WInOps Meetup. WInOps has been running now for nearly 5 years. We're going to have our 5th conference on the 23rd, 24th of September, but I'll tell you more about that in a minute. Obviously we co-found this with Prism Digital and Prism Digital and we've got Daniel over there from the UK DevOps Collective who has been organising all the speakers as well. So yeah, funnily enough, we are actually sponsoring tonight. So we pay for all for the drinks and stuff. So if anybody wants a job, please go and talk to Gareth wherever you are. He's not in the room. Okay, fine. So one of our recruitment team is here. One of the speakers, the first speaker up, Gareth, that works for us as well. There's a couple of other DevOps group engineers in the room. So if you're interested in doing a career in Azure and AWS and DevOps in general and Agile, come talk to us. Yeah, Gareth. There is Gareth. He's just not in the room. Okay, and Alex, Marcus for your more generic recruitment needs for Prism Digital, and Daniel. Guys right there. What else did I talk to you? Oh, WInOps. So we are low on numbers this year for WInOps, so we are desperate to get some more people to come along. So we have some probably some free tickets we can give away if you're interested. Basically, it's a 2-day conference. Day 1, we've got workshops from Octopus Employee Chef, Chocolatey, Puppet, and us, DevOps Group. The 6th slot is probably actually going to be Puppet as well. To wait on so it's not that nice to talk. So we've got lots on the 2nd day, the Tuesday. We've got lots of great talks from Abel Wang and English Schmidt, both part of the cloud developer team in Redmond. We've got a whole bunch of people. We've got a lot of MVPs coming and talking. A wide range of talks, everything. So funnily enough, I picked John O'Connor's talk, Challenges and Wins of the Distributed Team, before Puppet actually came on board as a sponsor. So I kind of reverse engineered them into being a sponsor. But that's an interesting talk, because we try and make a mix of topics. We've got some deep dive technical topics, we've got some sort of pretty hands-on type stuff, and we've got some stuff that's a little bit more sort of intellectual, I guess, to try and challenge, not just do the technology, but we care as much about ways of working as well. So basically, tickets, if you use the 20% off code, it's $200 for a 2-day conference, which I think is exceptional value. I mean, the training from Puppet Chef alone on the first day is, well, they charge you $400. It's £400, I think, for Puppet Fundamentals, which is a half-day course. So, yeah, I think it's a great opportunity. So please come along and spread the word. Today, what's done? Yeah, introductions. Maybe sort of ahead of schedule and crack on a little bit earlier. So Gareth is going to be talking about Terraform. How long have you been with us now?
Fast approaching, yeah.
Time flies. Been with us about a year. So we've got lots of real-world sort of customer stuff to talk about. And we've got Sam from Willis Towers Watson. Sam is also an MVP. Where have you got down there? Sam is also an MVP. Going to talk about providing SMB shares using in Microsoft Azure. As much as it makes me puke to see the words SMB shares, unfortunately, it is still a requirement for many organisations. And if you can solve some of these problems, you can solve some of those barriers to adoption that are largely in people's heads and not actually in reality. But it's an interesting topic, so I'm looking forward to that. And then, if you want to tweet out some pictures, use the hashtag WInOps and tag WInOps London. That's basically it. And with no further ado, I will hand over to Gareth.
Testing. Everything here okay?
Fantastic.
Hi everyone. I am Gareth Evans. I'm one of the senior engineers at DevOps Group. And today I'm going to be talking to you about change control Terraform and a bit of a personal journey through what I thought was going to be a simple task that just snowballed into this monolith that took the best part of a month. So this is pretty much going to be my perspective on something and a bit of an insight into how I handled, first off, creating something based on a requirement, and secondly, improving it. And then we're going to take a look at some of the lessons that I took from that and things that I'm going to be applying to my work going forward. So, unless you weren't listening earlier, it's me. I'm an engineer with DevOps Group, and as I mentioned to Steve earlier, I've been with the company fast approaching a year now, so a lot of varying scenarios and a lot of really great exposure to some other problems and an awesome opportunity to learn. So, problem arises. First thing that we're going to think of is how do we stop this problem happening? Firstly, as a fix. Secondly, how do we stop this ever happening again? And to me, this initial problem, and it's quite embarrassing to admit, but I added a duplicate machine to Active Directory. So I added a virtual machine which had the same name as the virtual machine that already existed in the domain. Now, if anyone has experienced this, I'm not going to shame you and ask you to raise your hands, but you'll probably know that the machine that first existed doesn't tend to like that and will tend to run into some problems. So the problem that I ran into was the machine lost trust with the domain, and all functions that ran on it essentially went down the toilet. So one of the challenges that I had as a result of that was this change happened as a result of change control, and naturally a lot of confidence was lost during that change. Well, we change controlled it, okay, we identified it, but there was still a significant outage while that machine was being brought back. So it started me thinking, why do we need to prevent outages in the first place? But also, what is the cost of them? So in looking at reducing the risk of this ever happening again, I did sort of go down this route where I think, well, as a customer, that's going to reduce the risk in all future deployments. In turn, that's going to improve my confidence in the change process. And then if each of those changes is created in such a way that we minimize impact with each deployment, then that's further going to bolster the 2 points above it. And then the fourth one, the fourth component that caused this issue in the first place was human fault, human error. And it's a room full of humans here, so how do we reduce that? We try and remove that human involvement as much as possible. Now, at no point are we ever going to go sort of, well, we may, but not in this project at least, are we going to go fully autonomous. So one of the things that we need to keep in mind is how do we deliver the most value? And that is with a good balance between time spent as a human developing something that will work, and then that will essentially help out with all of the points above. And that's the approach that I took with resolving this. So just to give a bit of background on the environment that I was working on, I'm going to paint a bit of a picture that hopefully isn't too dissimilar to what you see or you're working on at the moment. So this corporate environment, it was multi-subscription. We were deploying infrastructure as code via Terraform. And that infrastructure was mainly consisting of virtual machines, which then had PowerShell and DSC run on them to configure them. And then on top of that, we also had a source-controlled repository to keep that PowerShell and Terraform in. And that code was deployed using the Azure pipelines to build and then released using custom build agents. So the way that Terraform was set up was we had separate backends per subscription. So if you think of it from the perspective of the blast domain, if a Terraform deployment goes poorly, or if it's basically if the state file gets corrupted, we want to minimize that impact as much as possible. So we're going to try and split that out per subscription and make it as small and contained as possible. So within that Terraform per subscription, we're also working with modules as well. So the joy of working with modules is you write code once, you deploy it many times, you can repeat it without having to write duplicate code and copy and paste all the time. So the way that we structured our modules was we had generic virtual machines and dependencies, and they would be called each time we'd need, say for example, new infrastructure built. So we'd call the same generic module 10, 15 times, and we know that we've got a repeatable, scalable environment that's consistent each time. So, my app It was, we need a duplicate machine that's exactly the same as this one, and we need it over here to dev on. And now, for me, where I fell down, I didn't change the virtual machine name. I took things a little too literally, stood it up in the exact same way, and as there's one flat domain covering all of these subscriptions, when the machine was added to the domain using a custom script extension, everything fell down. So, I probably should have gone to the slide a little earlier, but it runs through some of the items that I mentioned. So, I know the problem, I want to fix it, I'm going to create a dev environment to create that fix on. So I want something in PowerShell. There's loads of documentation on it, and the beginner, where I feel confident that I can learn it to achieve this goal. So, one of the challenges that I faced initially when looking at a dev environment, I need 3 components for this. I need it to be cheap. I don't want to be spending everything on creating a solution that I'm eventually going to push into prod and then delete the environment. I want it fast. If I want a brand new environment, I want it then. I want it when my ideas are ready. And I want it very similar to what I'm going to be running in prod. But these 3, for me, this is where I ran into problems. So these 3 items, they sound achievable, but for me there was a trade-off. I could either have cost or speed, or I could have a very close replica of the environment I was going to be working on. To me, I took cost and speed. And that meant that I wouldn't be working with a pipeline. It meant that I'd be running simple scripts from my machine. I'd be working in an environment that was single subscription. I'd be working on a different domain that consisted of 3 or 4 scattered VMs, as opposed to a full-scale enterprise domain. So, the initial script that I wrote to sort of work around this item, I don't know whether you can see that okay. I can see some smiles from some of the PowerShell experts in the room. It's not the best. I'll be the first to admit. I'm learning PowerShell, as you can see from this. I'm still pretty early in that journey. But just to walk you through this, at the top, we've got some arguments that I'm passing in at the command line level as environment variables. Then this second block is essentially a bit of insurance for me. So when I'm creating a virtual machine, I don't actually know whether it's going to be able to reach that DC. It's also a machine that's not on the domain trying to connect to a machine that is on the domain. So you've got a couple of items there that are going to help get around some of those potential issues that may arise and help us flow a little better. The third section, I can see some wins in already. I'm creating some secure credentials, and that is going to be used to pass into this long line here, which I've had to cut off because it's getting a bit ridiculous. But this is going to invoke a remote command on the domain controller. So we're going to connect to the computer name, my test DC, test.net, using the credential created just above. And it's going to use this script block, which is going to get the AD computer with a name like computer name that's running it. Really simple. Does my machine name exist already in Active Directory? If VM name is empty, VM name is not in AD, domain join script can be run. If it's not empty, that machine name already exists. Throw an error and give that VM name as that error, pretty much to try and reduce that. Now, it's not the best, it's not ideal, I'll be the first to admit that, but it got the job done. I was able to run this and be able to see whether the machine that I was working on existed in the domain already, and it gave me quite quick feedback as I was already on the machine running this. So, do I integrate this into my Terraform, or do I separate it out and introduce it into a pipeline? Terraform target. Within Terraform, do I now have to rewrite the code to accommodate this step? Whereas previously, it would create a neck, join that to the newly created virtual machine, run the join domain extension. How do I split out those steps? How do I create the virtual machine its dependency, pause, run that script, then join into the domain if that test passes? And my initial thoughts on that was by using something called targeting. So really basic test environment pipeline here, initiate the Terraform, not even plan, just going to go straight into the apply and auto approve, and we're going to target, we're going to create an Azure virtual machine, a neck, and a public IP. That's all that's going to be run. So the way that this is handy is I don't have to go through a known working generic module and rewrite that and test it in every use case that it's used in. I can keep that exact same script and I can split it out. So here, where I've got the target as virtual machine that's being created, I've got a second step here that's going to run that script that I've just shown you. And then if that passes, we can then come down to the next step, which will join that machine to the domain. So, some of you are probably thinking this. If I'm running that script, what happens if it never connects to that DC? I'm going to have a blank variable. It's going to pass the test. But there could still be duplicate VM names present in the domain. And again, a little bit of a workaround, and this is probably going to show my inexperience, but I'm going to add a new test here, where I'm going to run the exact same command, and all that's going to do is print out the DC's name and create that as a variable. So it's going to connect to a remote machine, it's going to ask it its name, and then it's going to save that as a variable. We're going to run the same test on it. Now if that returns null, if that variable is empty, we're going to say at some point along this stage, this invoke command isn't working. It's not connecting to the machine because it's always going to put a computer name environment variable when it connects. So something above that is broken. So only when this invoke command step is run, we'll then proceed to the same command that we ran earlier and the same test. So to me, that was a bit of further assurance that I'm actually running the script on the machine and it's being run remotely. So following that, is that deployable with the infrastructure that I've created? Well, I've separated it out into targeted Terraform, but now that's going to mean that I'm going to have to go through this entire enterprise infrastructure, edit all of the pipelines, split them out into multiple steps, and change quite a lot manually. So for me,
Sorry.
So to me, this seems like something that should and could be automated. So I'm going to try and introduce this into Terraform. So we're going to have the same Terraform running. We're going to create a virtual machine and I'll call this dependencies. And then as soon as that virtual machine is created, as this depends on tag highlights, we're going to run a virtual machine extension. Now this is going to create, well, this is going to follow that function test, the script that I created earlier, and that's going to run it on the newly created machine. So now this is going to be introduced into the Terraform. We no longer need to break it out into 2 additional steps. We can now flow straight from creating the machine, running this test, and then if that succeeds, well, that depends on tag in the boolean join extension. And if this succeeds, it can trip along. But if this PowerShell script fails, it's going to tank the entire deployment. So PowerShell's going to fail. It's going to work backwards up from there. Terraform's going to fail. Python's going to fail. It's still not quite right. We want that script in source control. So we're going to need to redesign. So in this scenario, I moved the script over to Azure DevOps in the repos there. And I started thinking, how do I get this file from Azure DevOps onto that storage account so I can pull it in the same way, but I've got that guarantee that if that script is changed by another member of the team, they forget to tell me I don't want to be running the old script. If there's any improvements to it, I want to be running the best version of that I can. So do I upload that script as a job in that pipeline? Or is this again something that Terraform can absorb and take some of that overhead over? The answer is yes, it can. So a pretty basic function within Terraform, storage blob. Take this file from the repo, drop it onto Azure storage. If this exists in the modules folder, it'll be dropped onto Azure storage, right? How does this work if we're pulling that module not from a local directory? How does this work if this module is further source controlled? Will this still work if that module is being pulled from GitHub? If it's one of the public Terraform modules? No, which was my discovery, my frustration. So that script, even though we're trying to add it to the storage blob, the build agent is not going to know where to pull that from. So when we're pulling the module from be it GitHub, Azure DevOps, or a Terraform public repo, it's going to sit on the build agent that's going to sit in a Terraform folder that's dynamically created at the point of initiation. So it's not going to look nice like this. It's going to have this massive string of a name, and it's going to change each time. So how do we get around this issue and still keep that script in source control, pull it from Terraform, and have it dropped onto that storage account? And the answer is to get rid of this. Just remove the need for modules and drop the function test in the root folder for every Terraform deployment that's going to call it. Now, I know this is the sort of thing that I've tried to avoid in earlier steps, but this is something that, for me, became unavoidable. So this meant that I had to replicate this function test or this script in each deployment that I was creating. So each repository that was going to call this module, I've now got this script in. So I've got jobs set up that can track it and make sure it's the same each time. But for me, this is one of the hurdles that I was unable to get over. And sometimes, instead of spending an extra week on this, I have to sort of hold my hands up and say, this isn't working. I'm not going to get this done in the time that I have. It works as is if I push it up to the root level, and that's fine. It works, it delivers value, and I can get on to other stuff. But what happens if I'm trying to deploy a module to multiple subscriptions with the same Terraform code? Is this something that is appetite for, or am I just adding pointless complications? So there's a really nice way of doing this within Terraform. That means adding a separate provider block, a separate subscription ID, and then calling that subscription alias each time that Terraform is run. So if you extrapolate this back, we've got Terraform root level calling a module from elsewhere. That module is then calling another service principal to drop a file that exists at the root level on a storage block, and it just gets too noisy. The benefit that we get from having this is negligible. So this was something that just got trimmed. There's no need for it. It adds zero value. So drop it and move on. So as part of this, I'm creating a storage account and I'm dropping a file onto there in order for Terraform to call that file. But what about that storage account after that file's been called? Do I still need it? It's just sitting in the corner gathering dust until the next VM is created, and I've got a potentially old script on there. I want to reduce the cost. I want to guarantee that the script that I'm calling from that storage account is the nearest each time. So I'm going to create a cleanup task at the end of my pipeline to get rid of that storage container. So another targeted deployment. So as soon as this pipeline's been run, I'm going to run a destroy command and target that at just the storage account and the resource groups of that storage account existing. So I'm keeping this nice and clean. There's no, hey guys, there's this weird storage account knocking about. Do we need it? What's it for? Please don't delete that. Everything will break if you do. We're creating it fresh each time. We're dropping the latest version of the script onto it. And it's not needed. So why would we keep it there? So then there's this additional PowerShell step here, display logs. Now that's something that came about from the start. So when we're running this, one thing that I found was it's really hard to get feedback on this. So I want some pipeline feedback. I want fast feedback, and I want valuable feedback. So what if that PowerShell breaks? What if Terraform doesn't run? What if the pipeline just stops? All I'm going to see from the pipeline logs is a failure. I'm not going to see what that PowerShell failure is. I'm not going to see which VM it ran on. All I'm going to see is a 0 in the Terraform and a load of red text. So I want that granular feedback, and I want it in the pipeline. I don't have to drill down into each VM each time this fails, just to work out which machine it's failing on. So one of the nice things about working with virtual machine extensions is they always drop their logs in a pretty consistent place. So whenever I'm running that custom PowerShell script extension, it's always going to drop a log in the same location. It's always going to have a .status extension on it. So we know where the log's being kept. Let's just print that as a step in the pipeline. So while I'm running this pipeline, I don't really want it running an additional step when it's not needed. If Terraform apply runs and the machine is joined to the domain, I already know that this has worked. I don't need an additional step to tell me it's worked. So I've created a trigger in this that will only run this particular job if the job above fails. If Terraform apply doesn't fail, this is never run. So the end scenario is display logs doesn't get run anymore. We jump straight from Terraform apply to destroying those storage accounts. So as it stands, that's where I'm at with this particular task. But I still feel like I can make it better. But that challenge comes as a bit of a trade-off. Yeah, I can make it better. Yeah, I can spend additional months working on it. But how do I balance that value to time ratio? What are the things I can look into? Can I improve that PowerShell? Undoubtedly. How long is it going to take me to learn that and revisit it? Can I improve that pipeline the way that it's called? Is there a way that I can avoid using a storage account to call that script? Can I remove that additional step? So these are all things that I'm still floating around in my head to try and work out, is there a way of streamlining this? Can it be improved? Are there any unnecessary parts that can be removed? And with that mindset, it kind of allows me to step back further and look at some of the things that I've discovered whilst working on this. Number one, if I'm developing anything, going forward, I'm going to need that to be on as close an environment as possible. So the amount of time, and I'm going to use the word shoehorning here, the amount of time I had to shoehorn an idea into prod was really frustrating, and that was a massive time sink. So for me, if I'm creating something that has almost full parity on the environment it's going to end up in, then that's going to reduce any time spent here. If I'm designing it and developing it to run through a pipeline, then that's going to reduce that time spent trying to make it work with the pipeline. There's no point in moving from, oh, this is a script that works on my machine, to, oh, when I put it in the pipeline, it just dies. I'm going to spend another 2 days troubleshooting that. So again, we're clawing time back on each of these. And again, something that I'm a little bit embarrassed to say, looking back, that source control it from the start. There's no point in having something that I'm working on sitting only on my machine, and then it becoming this massive burden about, I need to call this from the central location. Gone are the days where you can just call a script from within its root folder. So having these things in mind, the next one is something that I was able to cover a little bit in my development, but it's not really something that I'm fully happy with. I can get better feedback, I can get more granular feedback, and I can probably get it in a faster way. So if I'm troubleshooting through a pipeline, one of the things that I'm finding is quite frustrating is I'm going to have to wait for this entire pipeline to run. Now, it's okay if it's just creating a storage account, if it's creating a virtual machine, but when we're talking about a massive IaaS deployment where we're spinning up this fresh environment, we've got 15 VMs, there's custom script extensions being run all over it, you're looking at about 2 or 3 hours to get a decent bit of feedback from that. Now, if something's going to fail on the final step, that's too late. You've just wasted 2 hours waiting for something that's no good to run. So it's kind of made me take this new approach where I'm just going to get it in a working condition and build it up from there. The minimum viable product. So if it works, that's fine. I don't want to be spending a month on something and the value is only added on that final day of the month. If I'm creating something, I would rather have it valuable from as early as possible and then build and expand from that. And that's one of the things that I really found valuable in this experience. It gave me a much more in-tune look at, well, that in practicality. So, pretty simple task. I don't want any duplicate machine names being added to my domain. But down the line, it snowballed a little bit. And this was my flow. And I'm here now. Is it complete? I don't think so. I've still got a lot to improve on. But it works and it's delivering value. And that's the most important thing at the moment. Are there any questions?
Are you going to run it?
The fear in my eyes. No, I'm not.
Where do you save your state?
What's that, sorry?
Where do you save your state?
My state file, that's in Azure blob storage. Yeah. So during tasks, there was just a local in it that was saving step file locally on the build agent. It would be deleted after each run. But yeah, for the real environment, it would be in Azure Blob Storage.
Was the script reviewed by security team because you worked in an enterprise environment?
It's not been pushed to prod yet, so that's where a lot of those.
So you will have to modify that a little bit. Trust me.
Anyone else?
Did you enjoy it?
What's that, sorry?
Did you enjoy it?
You trying to choose my words here. It was challenging and frustrating. I can enjoy it looking back now, but at the time, no, it was really frustrating. It seemed every step that I'd make in the right direction, or as I thought when conceiving that plan, as soon as I tested it, it would just come crashing back down, and I'd have to choose a different avenue. So if I ran through all of the failed experiments that I took trying to do this, you'd probably be here for a couple of days.
You might create it to fail on the plan rather than the plan, so you don't actually.
So because we're running the script on the machine itself, we need it to be applied before we can get that feedback from the machine. So one of the things that I did look into was using that plan and running it against existing state files, just to see whether is Terraform aware of this machine. But because of the nature of the environment, there were machines being created using ARM templates, there were a couple of manual builds.
Not by us, I'd point out things.
Of course. Anything that wasn't known by Terraform would have fallen through the gaps on that one. So it was seen as a little bit too risky.
Where was the VM name coming from? Was that being generated by your modules?
So the VM name was essentially just interpolation from the module down. So we kept it pretty standard within the module, so it would always be region, name type, things like that. But then the particulars that would build those names out would be passed in, depending on which environment it is as well.
I can show you some really awful regex. Pull the VM name out first, so you don't have to build it.
That does sound pretty cool.
Sorry, is there any other kind of reject?
I was going to say.
Okay, that's everyone.
Great.
Thank you.
Thank you. Mute the audio for a couple of minutes.
Okay. So SMB shares in Azure. I too feel a little bit ill when I talk about this concept. Nobody really wants to be working with SMB in the cloud, but nearly everyone gets forced to because we're all stuck with legacy applications. Or at least most people I imagine. If you're not, then I hate you, you can leave. But you know, one of the first things a lot of people do when they try and move to the cloud is lift and shift existing applications. And if that's Windows, often that's going to come with a requirement for SMB and SIFs. And we're kind of stuck with that, so what do we do about it until we can get those applications rewritten or gotten rid of and do away with this horrible concept of SMB? That's me. I'm a solutions architect for a company called Willis Towers Watson. We do a lot of work with building software for actuarial modeling financial services. So, as you can imagine, we've been doing that for a long time. We do have quite a lot of legacy applications, which I get stuck with. Got a lot of nice new shiny ones as well, but the ones that take up a lot of the time are unfortunately some of the legacy stuff. But I'm also an Azure MVP, so that's sort of helped me get through some of these problems, but this is a real problem that I had to deal with where we were looking at a particular application that needed SMB shares, and not only that, it needed pretty high performance SMB shares, otherwise the application wasn't going to work properly. Some contact information on the bottom there. The slides from this will be on my GitHub afterwards. At the bottom there is github.com/Sam-Kogan, and also got quite a few blog articles on this sort of thing on my blog there, samkogan.com. So why are we talking about this? What's the problem? As I mentioned, legacy applications need SMB shares, and we want to put them in the cloud. We understand that, but why is it a problem? Well, cloud providers, and this isn't unique to Azure, AWS has similar issues as well, are not really set up to deliver storage in a way that will work in a clustered manner. And so we'll look at that in a little bit more the next slide. But what that means is we've got to move these applications into Azure, and we've got a requirement for providing shares that are performant and that are reliable. So most of these applications we're going to want to run in production, just shoving a single VM up there with a file share on it isn't always going to be enough. We need high availability, and that's a requirement both from the business, but also that gives us requirements in terms of Azure. So to have a highly available set of VMs in Azure, you can't just deploy one VM, you need to deploy 2 virtual machines to distribute the workload. Well, if you can't cluster them, how do we make an SMB environment that uses multiple machines, so supports that SLA without that cluster? Is a problem. We've obviously got a requirement for high availability from the business itself, and then we've got an additional requirement there to deal with disaster recovery. How do we actually make this available in another location should a disaster strike? These are all problems we've got to try and deal with. And the classic method of using a failover cluster isn't going to work anymore. Azure does not support sharing storage between the virtual machines. A disk in Azure is attached to a VM, and it is the only VM that can use that disk while it's attached. So failover clustering with shared storage isn't going to work. We need to come up with a new solution to be able to deliver SMB shares without that. So that's the rest of the talk. How do we do that? And these are the things we're going to look at. Now, before we get into this, I will sort of add a warning. So I delivered this talk, I've delivered it a few times. The last time I did that, we got to the end of the talk, and one person in the audience comment was, well, that's depressing. And the reason for that is all of these solutions we're going to look at, not one of them is perfect. They all have upsides and downsides, and you're going to need to sort of think about these and determine which works best for you. So don't think you're going to be able to get one of these solutions and go, okay, that's perfect, it does everything I want, let's get on with it. There are things you're going to have to consider. And so that's what we're going to do, is have a look at these different solutions and figure out which one might be the best one for you. So the first one is Azure Files. I'm doing this one first because if you have a conversation with Microsoft and you mention SMB, before you finish the sentence, they will tell you Azure Files is solving the problem for you. Azure Files is Microsoft's implementation of SMB on top of blob storage. So it's a PaaS-based solution for delivering shares, SMB shares, NTFS and NFS is coming at some point. But it's a PaaS-based solution on top of Visual Storage. And it has a number of benefits that do actually make it a pretty compelling service. And it's certainly much better now than it was perhaps even a year ago. So being a PaaS service means I don't have to care about high availability, disaster recovery, all those sort of things. It's done for me. So Microsoft are replicating the storage the same as they do with Blob. 3 replicas in region, 3 replicas in another region if you pick geo-redundant storage. That's all taken care of for you. It's encrypted at rest. It's pretty cheap, unless you look at the premium version, which is a bit more expensive. It supports SMB 2.1 and 3. Nobody supports SMB 1 anymore, and if you try and use that, you shouldn't be in the cloud at all. It has built-in backup as part of the solution now. It's in the fairly new edition. It's about a year old. But you can now do snapshot backup as your files. There is a preview of integration with Azure AD domain services. That should have an extra letter from there. Of Azure AD domain services to provide ACLs on top of file storage. So it is a preview, and it only works with Azure AD domain services, which is Microsoft's hosted AD, which is different to AAD, and I can go into that in a lot more detail if somebody wants to, but it works with that. It's in preview. But if you wanted to hook it up to proper AD, on-premise AD, you can't do that at the moment. And there is a recently GA premium version which offers fairly significant throughput increases. So on the face of it, it's pretty good, but it has a couple of really glaring issues which might stop you using it. The biggest one is around security. So if you're going to hook up an Azure file share to your Windows server, you're effectively running some PowerShell or using some command prompt to run NetUse or the PowerShell equivalent to actually connect to the storage. And when you run that command, you're passing in your storage account name and your storage account key in plain text. There is no way around that at the moment. And so if you are going to be hooking this up to machines that other people have access to, even client machines, these credentials are going to be in plain text. Somebody can take those credentials, walk away with them, and do what they like to some extent. Now, this is slightly better now than it used to be. So this line here with external access I crossed through. This is slightly better than it used to be because you can now use service endpoints to restrict a storage account from being accessed outside of the virtual network you define. So you can prevent somebody walking off with that key and connecting from home and so on. It's not quite as bad, but in my view, it's still a fairly significant problem. Now, if you're going to be doing this all on back-end servers through service accounts that no one has access to, maybe it's not so much of an issue. But if you're concerned about that being in plain text, then it may not be the service you want. The other thing is that unless you're using AADDS, as I mentioned before, there are no ACLs on Azure files. So everything is permissioned solely by the storage account key. Hopefully that AAD integration is going to roll out into AD at some point, and then we will have ACLs. But at present, everybody has access to everything. Performance is a problem if you stick with the standard files. So the throughput on the standard files is about 60 to 80 megabytes per second, which is not particularly great. If you move to the premium version, it ups significantly to about 3.6, I think it is, gigabits per second, which is a fairly significant improvement, but you're paying for that, fairly significant increase. File size limits have been increased recently as well to 100 terabytes, so hopefully that fits most people's needs, but it used to be 5 terabytes. And there is a limit on file size, which is 1 terabyte for an individual file. So, Azure Files is a nice solution. It's quick and easy to use. You can literally set up a file share in a couple of minutes, connect to it, use it. It works great in that manner. But in my view, the security concerns around that are a fairly big blocker. I'll quickly call out an addition to files, which is file sync. So this is a feature that allows you to use Azure Files to synchronize files on premise. So effectively, you have an Azure file share, which is your main source of truth. And then you synchronize that down to on-premise file servers or VMs in Azure or any old Windows machine. And you can put files into that file share on the Windows machine, they'll get synced back up to Azure Files and so on. So Azure Files becomes your actual store, and you can back that up and you can reference that. But the endpoint you talk to it through is your file service. This has a couple of benefits over plain Azure Files. Firstly, because your actuals are preserved. So you do get access control lists on the actual Windows VM. They are synced up to Azure Files and they're stored as a sidecar file. So if you access things directly through Azure Files, you don't see the ACLs. But if the only access point you allow users through is the actual file servers, then you still maintain those ACLs. And it has the ability to actually offload files up to Azure Files. So you only synchronize what's being used to your local file servers. And you have a stub file that if somebody double clicks on it, it will then put it down in Azure Files. So if you do have actual Windows VMs that you can use as endpoints, Azure Files can be combined with that using file sync to make a slightly better approach. Because then you're not storing that key in plain text, it's done as part of the file sync setup, and you've got those ACLs still. So that's an extension to Azure Files that might make it more useful, but obviously it relies on you having those Windows VMs. So I said earlier that having a single VM isn't really a highly available solution, but it's something that's worth considering if your requirements are fairly low. So the SLA for a single VM in Azure, if you use premium storage, is 99.9. So if that's enough for your requirements, then just using a single VM is a pretty simple option. You don't have any performance hit for application, your backup is straightforward, you can use the Azure backup agent or your own preference. It's pretty cheap, it's pretty easy to manage. But obviously it comes with a downside of you've got a single point of failure. So if the 99.9% SLA is not good enough, or perhaps you don't believe Microsoft that they can actually achieve it, then that's not going to be the thing for you. The other downside is obviously for maintenance, for your maintenance, patching and scheduled maintenance and so on, you're going to have downtime. You've got to reboot that machine, that is downtime. There's nothing else to take over for you. And you're really relying on backup for any sort of restore or disaster recovery or anything like that. So for a lot of people, it's not going to be good enough, but it's worth mentioning because it is very, very simple. Okay. On to more complicated things. Storage Spaces Direct. Anyone here use this? Familiar with it? Heard of it? Not many. Okay. So Storage Spaces Direct is a new feature in Server 2016. It expanded on the scale-out file server that was in 2012 R2. What it allows you to do is create a file share that is not only spread over multiple disks, but is also spread over multiple machines without having any shared storage. So effectively, when you're writing a file to the Storage Spaces Direct cluster, it is being written very similar to like you would do it in a RAID setup for disks. It is writing to, in a 4-server setup here, like here, you're writing to 2 servers in a parity bit or similar. It allows you to build a cluster that can survive the failure of a whole server or individual disks within those servers without needing to share the storage. Sounds like it's a out-of-the-box replacement for the file serving cluster. And if you look at the benefits, it kind of is. So it's a true active cluster. If you have machines that die, others will take over. If you have disks that die, others will take over for you. There's no interaction required. It's highly available, multiple machines, so you get the 99.95% SLA from Azure. It supports using Azure Storage as a witness, a cloud witness. You don't need another machine for that. Pretty versatile. Unfortunately, as you might expect, there is a bit of a problem with this. Storage Spaces Direct was designed and built for supporting workloads where you have large files that are held open for long periods of time. So in particular, VHDs, SQL DBs, those sort of things. And it works great for that kind of solution. Where you start looking at using it as an ordinary file server, where you have lots of small files, you have your Word files or PowerPoints and that sort of stuff, it can start to fall down. I personally have tried it, and we've seen performance degradation with smaller files. Weirdly, one of the things that was worse affected was Microsoft Access databases. which hopefully you can all avoid, but, but that's personal experience, was that Access databases didn't like it very well. Speaking to the product team at Microsoft, their response was basically, well, that wasn't what it was designed for, and we haven't really tested it. So it's really up to you to determine whether your workloads will actually run as expected or not. It's certainly going to work in terms of it will replicate and it will push them across multiple servers and so on. But whether the performance will do what you want is something you really would have to work out for yourself based on your workloads. It's also obviously fairly expensive because you are adding in more VMs and disks that are used for redundancy. So similar to how, if you're putting a mirror in a normal server, you've lost or a disk worth of space. It's just now expanded, so you've lost a server's worth of space because that's your parity. Another limitation is that under the hood, it is using the REFS file system to manage this. And that has problems around backup. So things like the Azure backup agent and the Windows backup agent do not support REFS. And so it's not easy to back this up. You have to get a solution that works with REFS. It requires Server 2016. When I originally wrote these slides, it was probably an issue. Nowadays, most people are moving down that route, so probably less of a concern. But yeah, this was the solution I thought was going to solve everything for me, and unfortunately it didn't. A storage replica is another new 2016 feature. So this is a solution that's really designed around DR and allows you to replicate data from one VM to another. So there's no fancy clustering or anything here. You are effectively setting up a replication partnership between two machines, and when you write the file to the primary machine, it gets replicated over to the secondary machine. You can do it synchronously or asynchronously, and it's done at the block level, so it's only replicating what's changed. SMB3 only, and it obviously it's able to work with your network constraints. So if you have a slow link between two regions and similar, it can work with that to optimize the actual replication schedules and so on. One nice thing is it actually does support replication of clusters as well, in particular storage spaces direct cluster. So you can have two individual storage spaces direct clusters and replicate them using storage replica. So if you combine those two things, you effectively have your cluster and your DR taken care of, but obviously the performance concerns around storage versus direct still apply. So I covered most of that. Block level, sync or async, combine this storage versus direct, also works with DFSR and databases as well. So if you want to front it with DFS, you can do that. It's intended for DR, so there is no automated failover process, unlike with storage spaces direct or with Azure files. If you need to fail over to the secondary machine, you need to run PowerShell command. That will trigger the failover for you. So there's no real automated way to do that. You also don't have any access to the non-active nodes data. So if you look at the machine, when you create a storage replica setup, you create some disks on the replica. So there's your data disk and a log disk, and you then configure the replica to replicate those two between the machine. If you look on the secondary machine, those disks won't be visible to you on that machine. So you can't actually access them until you either fail over or you break the replica. PowerShell only, so there's no UI for this. And again, Server 2016 and nothing else. Right, 2019 as well. NetApp, or Azure NetApp files, is pretty new. This is the first time I've included it in these slides, so it's been around in preview since about Christmas time. It went GA about a month ago, I think. This is a partnership between Microsoft and NetApp, where NetApp are providing actual NetApp frames in Microsoft data centers. This is not running on VMs, this is running on actual NetApp physical devices that are then partitioned and delivered to you as an Azure service. So it's all managed through the Azure portal. You're not doing anything with any of the NetApp actual UI or anything, but under the hood it is running on actual NetApp frames. And this allows you to provision an account and then multiple volumes under that account that are delivered on NetApp storage at different tiers. So there is a standard, premium, and ultra tier, and you pay appropriately based on those. It is more expensive than Azure Files, particularly if you look at the standard SKU. The standard NetApp is about twice the price of the standard Azure Files. When you get to premium, they're about the same, and ultra is a bit difficult to compare because there isn't an ultra premium, an ultra Azure Files, but ultra is pretty damn expensive. But it's a PaaS service, just like Azure Files. You don't have to deal with any infrastructure. You're buying space. It's high availability built in for you. Performance, it performs pretty well. Even standard performance, in my view, and I don't have any numbers of this, the standard performance is quicker than Azure Files. Standard performance. Redundancy is built in again for you. It's encrypted at rest, again, like Azure Files. It supports SMB and NFS, unlike Azure Files, you only support SMB at the moment. It can do snapshot-based backups. It's got that's a spelling mistake, it's got AD integration, so you can integrate it with your normal AD domain, and it will do ACLs and so on for you, which is obviously a step up from Azure Files, and I mentioned the SKUs. Unfortunately, there are, again, some downsides. At the moment, if you want to use NetApp Files, you have to request it. It's in GA, but it still requires whitelisting on your subscription, which takes a little while. I think, obviously, this is down to capacity. It requires physical machines, so they've obviously got to put them in place and they take the code capacity. It's only in limited regions, so it's in West Europe and North Europe and East US and Central US, and possibly a Asia Pacific data center, I can't remember. You can check that on the documentation. It doesn't support NSGs, which is an interesting choice. So when you deploy NetApp Files, you deploy it into a VNet. It's another one of those services where you have to give a dedicated VNet, a dedicated subnet even to the service. Will be a point in where every subnet is dedicated to something. But, so you have to give it that, but you cannot apply any network security groups to that subnet. I hope that NetApp have built in some security around protecting those devices in this subnet, but there's not really any documentation on that. It just says you can't use NSGs. So that's an interesting one. The other thing is you can't set any share permissions. So you can set NTFS permissions on ACLs, that's fine. You can't set any permissions at the share level, which for most people possibly isn't a problem because a lot of people just set share permissions to everyone. But if you want to use access-based enumeration to hide shares from people who can't get access to them, then the lack of share permissions is actually a problem. So that's might be a problem with some people. This one is a bit of a killer. There's no geo-replication at the moment, so everything is replicated in region, but there's no ability to replicate to a second region, either for just security, but also no DR, so you can't fail over to another region should there be a disaster. That's probably one of the biggest issues at the moment. It's on the roadmap. I'm hoping it's on the roadmap with customer-controlled failover, but it's not there at the moment. The other thing that really got me was the billing. So when you place files, and we noticed this when we were transferring quite a lot of files into NetApp Files volume, it does do deduplication and compression of files, but you're getting billed for the non-deduped and non-compressed size. So the only person getting the benefit is NetApp and Microsoft. And we raised it with them, and NetApp basically said, well, that's how Microsoft do it. So they're blaming Microsoft. This is a fairly recent thing we've had, so I need to get some more digging on this, but it's a fairly painful thing because you're paying for the benefit of storage you're not actually really using because of the back end. So that's painful. And then snapshots are manual. So you can do backups, you can trigger snapshots, but you have to trigger them manually. There's no automated scheduling of snapshots or anything at the moment. Again, it's on the roadmap. But this GA release, which is, in my view, a bit of a minimum viable product, doesn't have that either. So it's going to come along. In 6 months to a year, I suspect a lot of these issues are going to go away, and this will be a really good service. But at the moment, some of those key things are missing. Our old friend DFS.
Skip.
Yeah, I wouldn't advise it, but it does work in Azure. So you can do DFS replication. It allows you to replicate to multiple nodes. You can fail over automatically. It does give you the 99.95 SLA because you've got multiple machines, but it's DFS. So the failover is not instant. There will be a lag of 30 seconds to a couple of minutes before you fail over. The big thing the thing that made it not useful for me was the fact that it won't replicate files that are open. So if you've got things that are being held over for long periods of time, and ironically back to the original link, in my case, this was again access databases. Really hate access databases. If you're holding them open for long periods of time, they don't get replicated until you close them, which means you could have put lots and lots of changes into them that aren't safe. They're not replicated across to the other nodes. Performance of DFS is questionable, particularly if you are really hammering the file server. So if you are one of the applications we're running is basically doing model calculations over high performance compute grids. So there's 20, 30, 40, 50 VMs doing calculations, and then trying to write the results back to a file server. Now you can question the design all you want, but that's what it's doing. And we saw very quickly that the replication queue would build up on the DFS system really quickly. So you end up with a massive queue of data that would take hours to actually finish replication. By which time somebody's probably started another model running and filled it back up again. In my experience, DFS is also fairly prone to problems, just things not, replication stopping for no apparent reason or for spurious reasons. It's not synchronous, it's all async replication, and yeah, it's a bit of a pain to manage. But I put it on here because DFS is sort of the very minimum thing you could do. It's the sort of built into Windows, works everywhere, but I wouldn't recommend it. And the last thing I just wanted to quickly cover is third-party solutions. So there are options available to you from third parties that proclaim to solve this problem. Now, most of these are done as appliances. So all three of these are in the Azure Marketplace. And you go in there and you deploy them, and what they deploy is virtual machines in your subscription that are running their particular software that is doing something to abstract either Azure disks or Azure blob storage in a way that can then be presented as a cluster. So the bottom two there, DataKeeper and SoftNAS, do exactly that. They take Azure disks, put an abstraction layer on it, and then present it as iSCSI volumes that you can build a failover cluster on top of. And it's the one doing the work under the hood to replicate them between disks and so on, and just present Windows with an iSCSI interface that says, this is a failover cluster. So you can build a classic failover cluster. The NetApp Cloud Volumes on tap is a bit different because this is actually a Linux appliance which is providing NetApp solution but on top of virtual machines and disks and blob storage. It does both. I've actually implemented NetApp Cloud Volumes. It is actually quite a nice solution, but it's fairly expensive. And you're paying obviously for the storage and also the NetApp licenses as well. But what that does is take those disks and allow you to then use the NetApp interface to carve that up into shares. And also allows you to hook up blob storage as an archiving solution. So it's a fairly nice solution that does work, but you're paying for it. So we talked about most of that. The downsides there really are around cost and complexity and support. So you're taking on an application that you've now got to manage that is doing something pretty funky with the underlying storage. So it's not uncommon to see that sort of thing break, and you've got to manage that and learn the software, because most of the time when you buy these sort of solutions, you're paying for the licenses, but you're the one who's actually going to manage the software because it's an appliance, it's running your subscription. You've got to manage it. So they can work quite well. So the NetApp on-tap stuff we are actually using in production, and it works quite nicely. But you're paying for that, and you're moving away from trying to get into the platform as a service world And this is really IaaS with some extra bits on top of it. So I don't know about you, but certainly in my world, I want to use PaaS wherever possible because I don't want to have to manage virtual machines anymore. Not going to help us. So those are all of them. We've run through them fairly quickly. I did a longer version of this, which is about an hour and a half, but we've got some demos and stuff, but I don't think we've got much time for that today. But as I said, none of these are perfect. There are problems with every one of them. You need to look at them and say, well, which of these is less bad, or at least which of these issues do I not actually care about? Do they not impact me? And pick the one you want. Ultimately, the best solution is to do away with SMB altogether. But I think we all appreciate that getting these old applications decommissioned or at least rewritten in a way that can use native cloud storage is a little ways off. So find the compromise that works best for you, and then test it to make sure that your access databases still work. Test it to make sure it works for you, and consider performance in particular. So, if you do care about performance, if performance is a thing that you're going to be measured against, you want to test it because nearly every one of these can have performance problems if they're incorrect. That's about it. We'll just go back to the list. Should put that at the end. Yeah, so those are the ones I picked out. They are not every single solution, so there are other things available out there. I haven't covered things like Store Simple, which is the sort of on-premise replication box. Things like Luster and Gluster, the Linux file systems, HDFS, all those sort of things. A lot of those are very specific use cases, and if you're coming into this from a Windows world where you're used to clusters, buzzard clusters, or plain old SMB, they are a big change. So these are, in my view, sort of the most easily accessible and probably most popular ones in the Windows world. But if none of those work for you, then there are other things you could dig into as well. That's about it. Anyone got any questions? Yeah.
We're going to be moving some of our legacy applications to maybe Windows containers. Windows containers is ever suitable to use on an Azure platform.
Yeah.
We need SMBs for store applications. Do you have any experience in that field?
So fortunately, most of my container workloads are Linux, and the Windows ones themselves don't require SMBs shared. But you've got a couple of options really now. You could look at using any of these options. You could do them obviously if they're on the same virtual network as yours. You can invest a cluster and you can access them. I believe there are things out there running Windows file servers on containers. I'm not sure that would be a world I'd be able to brave, because you've obviously got to back that with persistent storage that is going to work. You obviously can use Azure Files as an actual persistent volume in Kubernetes. So that can be something you can actually attach the volume to more and more machines. So that might be something that's worth.
I thought there might be some limitations using Azure Files with Windows containers. It wasn't quite ready yet.
Yeah, it might be. It's not something I've actually delved into. I've certainly used it on Linux containers, but I'm not up to speed on the Windows ones, unfortunately. We'd say we are using them, but most of them are stateless.
Sorry, did I hear you correctly? Did you say you were using a script to connect to the SMB with the credentials inside the script? Why didn't you create an application to do that, or some kind of secure communication between it? So you've got, the only way you can access the storage is through mapping the drive, effectively. You can do that inside the application as well. So it depends what you need to do. So if your application is the one that needs to access the file share, then you can do that, but that involves you rewriting the application, or at least putting some code in the application to do it. So in the scenarios I was looking at, we had no resource to actually change the application itself. So anything that would have been done by scripts or similar sort of thing, or configuration management, that would have presented that share to the already existing application. If you can rewrite the application, then you can then use that to have the application connected to the share. And obviously then you can then encrypt the actual connection string. So it depends how you want to use it.
So we found a solution for this kind of case. So we were provisioning VMs deploy an application, and that application runs under a certain user. And for that user, you provide a custom script which adds credentials of that shared drive. And by default, it has access by using that SMB string to Azure files.
So you're putting them in the credentials store. So
We use the PowerShell and DSC, so PowerShell gets credentials which are being encrypted, injects into the script, which is not like output as a, it's just in memory.
Yeah.
Reusing into the script, adding into the Windows credential store, which being used to access that.
Files. Yeah. So it's not impossible to work around that sort of thing, but you've got to
It took a while.
Yeah.
And another thing you mentioned constantly, 2016 Windows, 2019 is a bit cloud friendly.
Yes, it is. As far as I'm aware, it's nothing I've delved into that much, but as far as I'm aware, 2019 doesn't offer any significant improvements in this space. The storage space direct is in there, and I believe it's been improved in some ways. I don't believe, the last time I talked to the storage team or the storage space direct team, they hadn't still done any significant work around general purpose file shares on it. That was about a year and a bit ago, so that might have changed, but I don't anticipate it has.
I remember SQL guys was quite happy to use the latest version and use Azure files as a SMB store because it's being supported like out of the box.
Yeah,
so that's a good trade-off.
Yeah, and with premium files it's a lot better. So one of the big roadblocks with Azure files was the performance. It was standard files was diabolical. But premium files is significantly better. So it's certainly a lot more viable option now than it used to be. If you don't need accuracy. Yeah.
With Azure Premium Files, with the new version of that now that's been released, one of the things we had before with this was that we could choose when to fail over the storage account, because obviously that's done from Microsoft's perspective. So if we needed to move the VMs over to another region, that the storage account would be in the primary region, which wasn't the same. Is that still the case now?
There is a preview of user-initiated failover, which came along about 3 or 4 months ago. I haven't seen it move out of preview, so I believe it's still in preview, but that allows you to trigger the failover yourself. So that will be coming into GA at some point, and that will allow you to control that. Yeah. Okay, thanks very much.